Hello everyone, welcome to the final presentation video of my Google Summer of Code 2023 project to replace GBridge. My mentors for this project were Jason Kreidner and Vaishnav Ashad. This is the diagram of the old architecture of Beagle Connect. Here, GBridge, a user space program, serves as SVC and performs AP Bridge role. As you can see, this setup was quite complicated and had a lot of moving parts. The new architecture is shown in the following diagram. As you can see, this looks a lot less complicated with no user space middleman. Now let us look at the current state of all the project goals set out initially. Implement Graybus node discovery over MDNS, implement SVC protocol in Zephyr application, implement AP bridge role in Zephyr application, create a Linux driver to serve as AP, implement HDLC communication between Linux driver and Beagle Play CC1352 over UART, test the complete new Beagle Connect setup with all the parts, get Linux driver merged upstream. While I have submitted patch to the mailing list, it has not yet been merged, so the last goal was only partially completed. Now let us try running a demo. So let me change my screen. Yeah. So we will use TIO to view logs from the Beagle Connect Freedom. And let me reset it. Yeah. Now we will search into Beagle Play and I will load the driver and it should start probing soon. Yeah. So let us check the output of IRU info, and as we can see, we have IRU temperature and optical sensor here. So I will now run a simple script which basically just reads the temperature info once and times it by like averaging the runtime of 100 requests. So Python reliability. It first does a simple warm up of like 5 requests so that we get out of suspend. And as we can see, we are getting somewhere in 45, 42, 42, 47. Yeah. So somewhere around 45 milliseconds. Uh, I have seen it go as low as 39 milliseconds response time when not using the debug mode in the Zephyr application. So, yeah, you should also be able to tell how reliable it is. So, the script basically exits if like even a single read request fails. So, and each of these requests does like 100 of read requests, so it hasn't failed in all this time, and I have continuously ran it for like a million requests, and it basically works fine as long as everything is plugged in correctly. So I will now break out of this and remove the driver, and as you can see from logs, it basically disconnects as well as it should, and everything is working cleanly. So let us go back to our presentation. So benefits of this project. GBridge requires GB Netlink and WPAN USB driver, which have not been upstreamed yet. Eliminating it would allow easier upstreaming since we now only have one driver to worry about. This in turn should help with industry adoption by providing strong guarantees as being part of the Linux kernel. This will also help simplifying the whole Beagle Connect stack, thus making it much easier to get started for beginners. And finally, anyone interested in just tinkering with the tech and maybe finding potential uses of Grabus can do it much easily with a Beagle Play and Beagle Connect without having a lot of setup to do. Here are all the important links related to the project. Feel free to check them out. So yeah, that's the end of the presentation. I would like to thank all my mentors, all the members of beagleboard.org and Zephyr Slack and Discord channels. I would also like to thank members of Kernel Newbies and Grable's mailing list for helping out with the Linux driver related questions. Finally, I would like to thank Google for running such a wonderful open source program. Until next time then.